So, good day everyone. I am Kiarra Fel Esteban, a fourth year BSEB student. So, for today, we will discuss about the response spectrum analysis of a 10-story building. So, in this lecture, we will be solving for eigenvectors, the participation of modes, spectrum curve, mode of response, and the peak response. So, since na-solve na ni Sir yung mode 1 to mode 5, ang isosolve na lang po natin ay ang mode 6 to mode 7. So, ito yung mga given na nasa Excel na binigay ni Sir. So, ito yung stiffness matrix, ito yung mass matrix, at saka modal frequency, the modal period, and the eigenvalue. So, ito yung mga values of this modal frequency, modal period, and eigenvalues for mode 1 to mode 10. So first is we need to solve for the characteristic equation, which is k minus the eigenvalues times the mass is equals to 0. So for mode 6, we will use the eigenvalue of mode 6. Mode 6 naman ito. So, ito yung k, minus natin siya sa eigenvalue times the mass. So, ito siya, yung result niya. So, next step, since unknown itong values na to, at saka since 0 ito, so we will come up to no solution. So, ang gagawin natin is to assume the topmost floor equals to 1. So, ito siya. So, next step is to eliminate the last row. So, ito. So, row. And then, next is to transpose the last column of the characteristic equation we solved earlier to the right side of the equation. So, since transpose natin siya, magiging positive na to. Tsaka na-eliminate na tong last row. So, magiging 9 by 9 matrix na lang siya. So, next step is inverse natin tong 9 by 9 matrix. So, ito na yung magiging results niya. So, pwede mong kunin yung inverse nito through Excel. Gagamitin mo lang yung inverse, then copy mo yung values nitong 9 by 9 matrix na na-solve natin. Then, mag-result siya sa ganito. And then, next, to solve for the eigenvector, itong 9 by 9 matrix na na-solve natin, na in-inverse natin, is i-multiply natin siya sa, in-equate natin, ito in-equate natin sa kabilang side na naging positive. So, i-multiply natin siya sa values na to, and then we will come up to the results of ito. Ito na yung eigenvectors niya. For mode 6. So, ito na yung mode shape niya from 1 to 10, and then ito na. So, same process lang lahat. Multiply, kunin mo yung characteristic equation, then eliminate, then transpose, and then inverse mo tong 9 by 9 matrix, then multiply sa sinolve natin kanina, transpose natin kanina, and then, yan, ikuha na natin yung eigenvector, and then the mode shape. So, ito na, same process lang for mode 7, mode 8, mode 9, and mode 10. Makukuha natin yan lahat. And then, ito na, mode shape ng mode 7, mode 8, 9, and 10. And then, next is, ito na. ito na yung summary lang lahat. Ito yung mode 1. Isa na yan. Itong mode 1 to mode 5, si sir nag-solve yan. So, meron na yan agad. And then, itong mode 6 to mode 10. So, yan, pinaghalo-halo lang natin lahat siya. And then, next is, we will solve for the participation of modes. So, itong first is the modal participation factor. So, ito yung formula niya to solve the modal participation factor. So, itong formula niya is in-inverse natin yung m hat para mas madali siyang makuha. So, since itong L is the coefficient vector, so ito yung formula niya. And then, we will use this later, the directional displacement vector. And then, generalized mass matrix or yung m hat. So, kukunin natin muna to, dalawa, para makuha natin itong modal participation factor. So, since, to solve muna natin yung L, we have to get the values of eigenvector na nasolve natin kanina. So, ito yung eigenvectors ng mode 1 hanggang 10. So, since kailangan natin siyang i-transpose na nakasabi dito, so, transpose natin siya sa Excel. Gagamitin lang natin yung equals, tapos transpose, tapos copy lang natin itong eigenvector na values. So, we will get the transposed eigenvectors. So, yan na siya. And then, next, solve na natin. So, minultiply ko na siya, yung transposed eigenvector times the mass. So, ito na yung result niya. Tapos, imumultiply natin siya sa directional displacement vector. So, equals to, so, ito na siya. Coefficient vector niya na to. So, meron na tayong L. Next is, kukunin na naman natin yung generalized mass matrix or yung tatawagan na lang natin M hat. So, minultiply ko muna yung transpose eigenvector times the mass, and then, mumultiply na naman natin siya sa eigenvector lang, yung transpose. So, multiply natin silang dalawa is, eto na yung results niya. Since kailangan natin siyang inverse na lang natin siya sa Excel para mas madali. So, ito na yun. Ito na yung inverse niya ng m hat. So, since meron na tayong mga values lahat ng m hat, inverse m hat, and coefficient vector, so multiply lang natin silang dalawa, and then, ito na yung sagot. So, meron na tayong modal participation factor. So, next is we will solve for the modal mass participation percent. So, ito guys, ito yung formula niya. So, EM is equals to MF over M total times 100%. So, para makuha natin yung MF, ito yung formula niya. Excuse me. And then, so, meron na tayong coefficient vector kanina na na-solve, and then the mode participation factor. So, multiply lang natin silang dalawa. And then, meron na tayong MF. So, yung M total, yung mass total siya. So, add lang natin sila lahat. And then, ito na. M total is 13.95. So, dinivide ko na sila agad. MF over M total is equals to this. And then, multiply natin by 100%. So, ito na siya. Ito na yung modal mass participation percent natin. So, next is the spectrum curve. So, ito na yung mga given na formula or given na ano. So, ito, CA is equals to 0.44, CV is equals to 0.64, and G is equals to 9.81. So, TS is equals to CV over 2.5 CA. Then, so, sinolve natin yan, ito na siya, 0.581818. So, 0.2 TS is na 0. So, sinolve lang natin to, minultiply lang natin siya sa 0.2. So, ito na siya, 0.116364. So, sa pag-solve ng spectral acceleration, kailangan natin ang modal period na given natin kanina. So, ito siya. So, in solving for spectral acceleration, we have 3 situations. So, to solve for this one, kailangan muna natin siyang kailangan natin titignan yung mga modal period kung saan siya fit or nababagay. So, for situation 1, tingnan natin if 0.2 TS is greater than TN. So, we will use this formula if it fits for the situation 1. So, yung pangalawa is if Tn is greater than or equal to 0.2 TS but less than TS. So, kung ganon, gagamitin natin tong formula na to. And then, ito naman, kung ang Tn is greater than TS. So, gagamitin na naman natin tong formula na to. Since the modal period for mode 1 is greater than TS. Ito. Yan. So, ito yung gagamitin natin na formula. So, ito na yung value niya. Then, sa modal period na mode 2 hanggang mode 6, since mas malaki siya kaysa sa 0.2 TS but less than TS, we will use this formula. And then, from mode 7 hanggang mode 10 naman, since mas less than yung mode 7 to mode 10 sa 0.2 TS, value ng 0.2 TS, so gagamitin na naman natin tong formula na to. So, ito na siya. Ito na yung mga values niya. And then, after that, we will multiply it by the G or 9.81. So, after nyan, pag na-multiply na natin, ito na yung results niya for spectral acceleration. Then next, we will solve for the spectral displacement. So, the formula for the spectral displacement is spectral acceleration over modal frequency squared. Is meron na tayong na-solve kanina na spectral acceleration at saka meron naman tayong given na modal frequency is squared na lang natin. So, ito na yung squared ng modal frequency. So, divide lang natin tong dalawa. So, ito na yung results ng spectral displacement. Siya. So, next is the lateral force. So, ito yung formula ng lateral force. Ito yung participation factor, then the mass, then the eigenvector, then spectral displacement. So, ito yung na-solve natin kanina na mode participation factor. Tapos, multiply natin sa mass, then the eigenvector mode 1, and the spectral acceleration. So, ito na yung results ng lateral force for mode 1. So, repeat lang yung process. So, ito na yung na-solve natin kanina sa mode 1, then repeat lang natin yung process from mode 2 hanggang mode 10. And then next, story shear force. So, since, gagamitin natin yung ito na values for solving this one. So, ito siya. Ito yung mode 1 ng lateral force. So, from mode 1 to mode 10, i-multiply lang natin yan. So, since summation ang nakalagay dito. So, summation of values for mode 1. So, tapos, sa mode 2, so, next is mag-plus 1 ka lang. So, sisimula ka na naman sa second floor ng mode 1. So, summation lang siya pa rin. Add lang natin ng second floor to 10th floor. And so on and so forth. Sa next na naman, sa third floor ka na naman magsisimula mag-add. 4th floor, tas 5th floor hanggang 10th floor, 6th floor hanggang 10th floor, 7, and so on and so forth. Hanggang sa 10th floor ka na lang. Then, yun na yun. Yun na yung results niya lahat. So, ito na siya. So, sinolve ko na yung shear force ng mode 2 hanggang 10. So, repeat lang yung process hanggang sa mag-come up ka hanggang 10. Then, next is the story displacement. So, in solving for this story displacement, we have to use this formula. So, ito ulit yung mode participation factor, eigenvector, and spectral displacement. And then, so, multiply lang natin silang tatlo, and then ito na. Ito na yung results niya. So, repeat lang yung process from mode 2 to mode 10. Ito na yung summary niyang lahat. And then, ito na yung modal lateral forces and modal story displacement na illustration. So, ito for mode 1. Pag ganyan siya, ang movement ng building. Then, sa mode 2 naman, pag ganyan, then pag ganyan. So, ito yung building. So, kapag may movement, may ground motion. So, pag ganyan siya, pag ganyan. So, ito naman, medyo same sila, pero opposite lang. And hanggang mode 10. Ito. May pattern siya, di ba? So, next is the peak responses. So, we have to use the formula of square root sum of squares or SRSS. So, in this peak responses, we have subtopics like peak story shear, peak story forces, peak story displacement, and peak story drift. So, we have to solve for this peak story shear forces and displacements and the drifts. So, ito. Peak story shear. We have to use the SRSS just like what I've just like So, ito, gagamitin natin tong formula na to. So, gagamitin natin tong story shear force na nakuha natin kanina sa modular response. So, color ko siya para mas ma-emphasize na ito yung gagamitin natin na values in solving this peak story shear. So, ito siya. So, since summation siya, i-add natin lahat tong values from mode 1 to 10 ng first floor. Tapos, isi-squared natin siya. And then square root. So, kagayahan na natin yung formula na to for peak story shear 1. So, ito na yung value niya pag na-solve na natin to. And then, yan na yung summary niya na sinolve natin. So, repeat lang din natin yung process na ginawa natin dito sa peak story shear 1. So, makukuha natin yung 2 hanggang 10. So, yan. The next is we will solve for the peak story forces. So, gagamitin natin ulit yung na-solve nating peak story shear. So, ang gagawin lang natin is peak 1 minus peak 2. So, makukuha natin yung peak story forces 1. So on and so forth. 2 minus 3, 3 minus 4, 4 minus 5, 5 minus 6, 7, hanggang umabot ka sa 10 floor. So, ayan na yung result niya. Then, next is peak story displacement. So, gagamitin natin ulit itong RSS, squared sum of squares. Ayan, SRSS. So, same process pa rin. Summation ng first floor, then squared natin to, tapos square root. So, ito na yung result niya. Same process lang din siya ulit. Solve nyo lang. And then, so, peak story dips na tayo. So, solving for peak story dips, parang kagaya lang din siya ng peak story forces. Parang inulit-ulit lang din. So, minus lang natin itong lahat. I mean, mamaya. So, before natin yung kukunin muna natin yung maximum inelastic response displacement. Tsaka meron na tayong R ng 8.5, which is overstrength reactor. Nag-given na din. So, solving for maximum inelastic response displacement, multiply lang natin itong nasa formula. So, 0.7 times 8.5, tapos yung peak story displacement 1 natin na nakuha kanina, which is 17.7354. So, multiply lang natin itong tatlo, and then we will come up with 105.5256. So, yan. So, ito na yan. Nirepeat ko lang din yung process. Ito, multiply lang natin yung peak 1 hanggang peak 10. Peak story displacement 1 hanggang 10. So, repeat lang yung process na mag-come up ka sa ganito. And then, next is, solve na natin yung peak story jigs. So, since na-solve na natin to, kukunin na natin to. So, magsisimula tayo sa peak story jigs 10. So, pataas tayo, hindi tayo pababa. Galing tayo baba. So, peak story jigs, displacement 10 minus peak story displacement 9. So, 1,349.0385 minus 1,314 minus, I mean equals 234.2904. So, yan ang results niya. So, ganito siya. 10 minus 9, 9 minus 8, 8 minus 7, 7 minus 6, 6 minus 5, 5 minus 4, hanggang umabot ka sa 1. So, ulit lang. Parang binaliktad lang din natin yung na-solve natin kanina. So, yan na yung results niya. So, since the modal period for mode 1 is equals to 1.1107207, that is greater than 0.7 seconds. Therefore, story drifts must not exceed to 0.020 times the story height. So first, we need to solve for the maximum drift. So ito siya, 0.020 multiplied by 3,000 mm is equals to 60 mm. So yan. Since story drifts 1 is greater than 60, so 60 yung gagamitin natin. The same as 2 hanggang 9. 60 pa rin yung gagamitin natin. Except na lang sa peak story drifts 10, which is less than 60. So, 34.2904 yung gagamitin natin. So, ito siya. Ito na yung illustration niya. 60, 60, 60, then 34 sa 10th floor. Yan na. Kuha na natin yung peak story drifts niya. And then, that's all. Thank you.